We're continuing on with inequalities with the quadratic. So the whole theme in this is that we can solve any kind of inequality and be able to tell if it's a true or false statement, and then be able to come up with all solutions, so all values that work. So to start off with, we're reminding you to plug in for these x's. So as a reminder, you square before you multiply. And this statement right here being greater than 0, the question is it positive? So if this is a positive, then yes, it's true. So yeah, it's just 16. 3 times 4 is 12. And then minus 10, so we have 4 minus 10 is negative 6, is not positive. And so since it is not positive, we would say it is not a solution. Determine if each of the following is a solution. I'm just going to write down no for letter A. So as I move on to the next one, do the same thing. Just remember to do the exponent before you multiply. So 2 times 2 squared, and then 13 times 2 minus 7. This time it can equal 0, but also be positive. Is that positive? Question mark. Well, 2 squared is 4 times 2 is 8. 13 times 2 is 26. So that would be 34 minus 7 is, well, I don't really care that it's 27 because it is positive. So this answer would be yes. 27 is bigger than 0, or bigger than or equal to 0. And then the next one, doing the same thing. Just the biggest mistake I've seen, and I'm still seeing it from a lot of students, is they're forgetting that when you square a negative, you get a positive. Negative 3 when you square it is 9. That becomes plus 3. I'm doing that math in my head, sorry about that. Which is 12, and then minus 12 is equal to 0. So is that a number that is less than 0? Is it a negative? No, it equals 0. So this is not a solution. And feel free, if I'm going too fast, to write down your questions and come to class and ask them. Because as we look at the next one, we can actually use a table feature on our calculator and determine if we can use this to solve this type of problem. Okay, so we're getting closer and closer to having a no calculator test, and all I would do is go to my y equals, sorry there's already something in there, and type in that function. So again, from the home screen, I just hit this button in the top left, y equals, and we have x squared plus 2x minus 3. And then from here, all I have to do is hit second graph, and I can explore my table and see what kind of answers we get. Now notice, if we look at the table, they go from -5 all the way to 3. So I need to scroll up till I get to -5 for x, and I can see 12, 5, 0, -3. 12, 5, 0, -3. I think it's -4 next, and then it comes back. 0, 5, and 12. And the whole point of doing that is then that can help us figure out what kind of answers, like when equals 0. So the way I would explore that is finding factors of 3 that add to give me 2. Well, that would be 3 and -1. So if you remember, we would write that out as x plus 3, x minus 1 is equal to 0. And then we would use the zero product property. Either the left piece equals 0 or the right piece is equal to 0. I keep messing up, sorry about that. X minus 1 is equal to 0. And if you subtract 3 over, you can see the correct answers are -3. And on this one, if you add 1 to 0, you get 1. And the whole point I'm trying to show is that these two were values on your calculator. Now, if I go back to the equation, we actually didn't care where it equaled 0. We cared where it was less than 0. So that's why, in part C, the zeros you found in part A are not part of the solution sets, is because we want less than 0, not equal to 0. And the other way of talking about that is that we want types of numbers that are less than 0 are negatives. So the way we would write our answer, if you notice, we want all of the answers between -3 all the way to 1. Why? Because those were all of the negative answers. I could go back to my graphing calculator and show you there's no other, if I just scroll down, there's no other negative answers. If I scrolled up, the only answers we want were these 3 negatives as well as all other decimals in between. Because that's the question, well, what if we let x equal 1/2? Is that still going to work? Is x equals -1.5 going to work? Is x equal -2.5 going to work? And so in set builder notation, you may have forgotten this, but the way we wrote this in set builder notation is we would write x with a bar here. And what we would say is we want values for x that are bigger than -3, because that was this number, but then smaller than 1. That would be this number. And on a number line, how we would write that is I like to see 0 written on your number line, and then I want to see your bounds like -1, -2, -3. I'm not very good at drawing. That doesn't look like I evenly spaced it out. But you put an open circle when it's not equal to, and then you want to connect these 2 dots. One more little way that you can double check this is if we're looking for negative numbers. Let me go back to my graphing calculator. If I look at my graph of this, oops, I forgot I changed it around. If we want negative numbers, those would be numbers that are below the x-axis. So if you look on this, you can see that we get negative numbers below the x-axis between -3 and +1. That might make more sense to you than everything else we've written. So on this problem, we're practicing again coming up with the answers, and I'm going to talk about a different way, and that other way is to test points. So if I ask you to solve this, what a lot of students will do is they'll change this to equal 0, and if I ask you to factor that, that's a difference of squares, so it'd be x plus 4, x plus 2, x minus 2. And so my answers would be x equals -2 and then x equals +2. So what I've seen some teachers do is they'll put a number line on their paper, and they'll ask students to test different values. So choose a number that is to the left of -2, like -3. Choose a number between -2 and 2, like 0, and then choose a number that's to the right of 2, like 3. And you can choose any numbers. You could do 1, you could do -4 over here, you could do 1,000,000 over here. And the whole thought process is if I plug in -3 into this problem, it'll either work or it won't work. So -3 when I square it is +9 minus 4 is 5. Is 5 greater than 0? And if your answer is yes, then we want that part. If I plug in 0, 0 squared is 0, minus 4 is -4. Is -4 greater than 0? No. So we cross that. We do not want that as part of our answers. And then do the same thing with 3, and you'll see it works. And so the answer that we want is values for x that are smaller than -2 or bigger than +2, which corresponds to option 3. So as we move on, we're doing more of the same thing, and we're practicing the set builder notation and writing the answer out. So if I were doing this quickly, I would just say, okay, factors of 36, that would be 9 minus 4. Except that's +5, so maybe make it -9 plus 4. So if I factor that out, x minus 9, x plus 4. Again, I'm changing it to equal 0 because then I can figure out that it's 9 or -4. So on a number line, I can test out some values. So I like to see 0 on there, 1, 2, 3, 4. Now this time it's or equal to, so I want to fill in when you have an equal to, let me circle it, equal to, you want a closed, we call that a closed point. C-L-O. Sorry, my handwriting's a little off here. So then you can test values. Now here's another trick, is I've seen some teachers just test 0. You can't always just test 0, but it's either going to be points on the outside for this problem or points on the inside. So it either works for 0 or it doesn't. And that's an easy one to test, because 0 minus 0 is 0, minus 36 is negative 36. Negative 36 is less than or equal to 0, so we want that interval. And you can test values outside of negative 4 and bigger than 9, but those do not work. So the way we would write our answer is we want values for x that are between negative 4 and 9, and we use an equal to this time because it can equal. Oops. So I can do the same thing with the next one. A little bit trickier though, but if you do your AC method, 5 times negative 12 is negative 60. Whoops, negative 60. And then I would just do 30 minus 2. And in my head, the way I think about it is just finding out that it's 5x and x. And the way to get to 30 is if I had plus 6 here, so I'm foiling, and then a minus 2 here, and it will work. Again, I'm setting it equal to 0, so then I can figure out quickly that my zeros will be 2/5, but then also negative 6. And this time when I check my intervals, again, I like to see 0. This time it's an open circle at 2/5 and negative 6. Open circle there. And if I were to check 0, because 0 is in the middle, 0 plus 0 minus 12 is negative 12, is not bigger. So we don't want that interval. We want the answers on the outside. So the way we would write our answer is values for x, where x is either smaller than negative 6 or x is bigger than 2/5. Now there are shortcuts to doing this, but I'm always nervous about shortcuts because some people do it wrong. Now these next two, notice that they're not equal to 0. So what you want to do first is get them equal to 0. And so I would subtract 10x to the right side. I don't know if you need to see that. But I would also add 8. I think I'll write it, like sneak it right in here. There we go. Minus 10x. But then also add 8 over to this side to cancel those two things out. And what you actually do is you cancel out those 8s. So now it is equal to 0, and I can factor out not only a 2 but an x. That's the greatest common factor. So now it's not acceptable to use x equals 0 as a test value. So let me scroll down just a little bit. There we go. So as you go to your number line, and you have 0 in there, closed, 1, 2, 3, 4, 5, 6, 7, closed because it's equal to, the test value I would use is 1. Is it true that if I plug it in here, I would get 2 minus 14 is negative 12. Is negative 12 greater than or equal to 0? And that answer is no, so it must be values on the outside. No, it does not work for 1. So in set builder notation, we would just have to write values for x such that, or satisfying that x is less than or equal to 0 or x is greater than or equal to 7. All right. I'm going to jump to this. I'm trying to hurry up with a few. I mean, it's all the same type of problems, except they're trying to get you to recognize, a slightly different thing. So like the first thing I would notice on this one is that we have closed dots. So it can't be option 1 or 2 because those are not equal to. And we want equal to. So as you look at the remaining pieces, all I would do is, this problem is saying that 0 works. So I would plug in 0 and see if we get an answer that works. So let's go to option 4.